This is class notes section 8.7, and I'm calling it B. The binomial theorem using Pascal's triangle. I'm not going to read that to you. I'm going to show you through the examples what you're going to do with that. So let's go down to the next example. It says to expand u minus 3 to the fourth power. So the first thing we want to do is generate the Pascal's triangle to the fourth row. Now remember, if you listened to my earlier videos, I started out by saying that when you make Pascal's triangle, when you actually make it, the first row is not really the first row. That's called the 0 row. So we start with a 1, and then the second row is 1, 1. That's the first row, really. The second row is 1, 2, 1. The next row is 1, 3, 3, 1. And the next row is 1, 4, 6, 4, 1. Now, with Pascal's triangle, since this exponent is a 4, we want to take the fourth row of Pascal's triangle. So again, when you count, you're not going to start with 1, 2, 3, 4. You're going to start 0, 1, 2, 3, 4, which means we are going to be using this row of Pascal's triangle. So this is the row we want with Pascal's triangle. All right, so let's go do the problem. So we start with the first number in Pascal's triangle. That's a 1. We put 1 times. Now we take the first term of the binomial. That's the u. So we do u in parentheses, and that's going to be to the fourth power. The fourth power is coming from this exponent. So that's the fourth power. Then we take the second term of the binomial. Now when you pick up the second term, you want to pick up the negative sign and the 3. So over here in parentheses, I'm going to put negative 3, and that's going to be to the 0 power. All right, then we put a plus sign. Now we pick up the second number in Pascal's triangle, which is a 4. And then we pick up the first term, which is a u. And the exponent this time, it goes down 1 from what it was previously. So previously the exponent was a 4, and it's going down 1, so it becomes a 3. And then we take our second term, which is a negative 3, and the exponent on it goes up 1. So since this one was a 0, up 1 would be a 1. So let's stop here for a minute and let me show you something. The exponents 4 and 0 have to add up to 4. 3 and 1 has to add up to 4. So the exponents are going to always add up to 4. All right, then we put another plus sign. And I'm going to run out of room, so I'm going to move it to the next row. Next number in our Pascal's triangle is the 6. So we put 6 times the first term, which is u. Now the exponent was a 3, so now it goes down to a 2. Our second term is a negative 3. The exponent was a 1, and it goes up 1 to a 2. Then we put a plus sign. Our fourth term in Pascal's triangle row is a 4. And then we pick up the first term in the binomial, which is a u, and that goes down 1, so it's to the first power. And the negative 3 goes up 1, so it's to the third power. And then we put a plus. And the last number in Pascal's triangle is a 1 times u to the 1 down from 1 is 0 times negative 3 to the fourth power. All right, so this is called expanding a binomial. So that's what it looks like to start with. Now we got to simplify that. First of all, remember that when you raise anything to a 0 power, anything to a 0 power is 1. So this whole thing becomes a 1. So now we have 1 times u to the fourth, which is just u to the fourth. So our first term is u to the fourth. All right, let's go to our second term. So for our second term, we have a negative 3 to the first power, which is a negative 3. And we're going to multiply that times 4. Negative 3 times 4 is a negative 12. And a negative 12 times u to the third power gives us our second term, which is a negative 12 u to the third power. All right, our third term, we have 6 times a negative 3 squared. Well, negative 3 squared is 9, and 9 times 6 is 54. So our next term is plus 54 u to the second power. And our next term is 4 times a negative 3 cubed. A negative 3 to the third power is a negative 27, and a negative 27 times 4 is a negative 108. So we get a negative 108 u to the first power, which is just u. And our last term is 1 times u to the 0, which remember that u to the 0 is just 1. So this is really just a 1. Anything to the 0 power is 1. And then we get negative 3 to the fourth power, and negative 3 to the fourth power is 81. So we've got plus 81. And so our last term is a plus 81, and that's the answer. So let's look at some things that happened. So the exponents, notice, are going down each time, 4, 3, 2, 1, and then 0. That's only because we only have a variable in one place. That may not always be true, but the sum of them should always be going down. So this is called expanding a binomial.